Hello and welcome back. Okay, in the last VGA video we worked on the tile data on breadboard. Now that's an interesting circuit. It kind of extended the overall effective resolution of our output, and in this video I want to take that breadboard circuit and convert it to PCB. Now we've got some other VGA circuits that we haven't converted to PCB, but I'm very interested in doing the PCB conversion in order of how the signal propagates through the system, so we can make sure we're properly testing everything as we go. So let's start off with a reminder of how the circuit works on breadboard, and then we can continue with the design for the PCB. Right, let's power this on. Right, we're not so focused on the CPU at the moment. These are the VGA circuits. Okay, so on PCB already, we've got the sync generation, the tile map, and then we've got the memory interface that sits behind them all. Now the outputs from the tile map are the tile index and the XY position within a tile, and we pass that into the tile data circuit, which then looks up the actual pixel we want to output. Now that pixel is actually a color index that goes to the palette before it's finally output to the DAC circuits, and the result of those is the actual analog signal off to the VGA display. The tile data is actually a very simple circuit, at least compared to a lot of the other circuits we've been doing for the VGA. We've got a memory chip, a set of multiplexers that are going to be taking the incoming address from either the address data bus or various bit swizzling between the index and the XY position within the tile. We've got an output multiplexer that's actually slicing up the 8 bits into two 4-bit colors. And then we've got some latches just for handling the timing. So with the CPU powered on, but it's not yet running, the VGA screen has actually just got an awful lot of random colors on there because the RAM is uninitialized, and that's going to be the RAM in the palette, in the tile data, and the tile map. So let's actually run the CPU and see what we get. Here's the logo that I built into the stub loader. And here's the current version of the monitor loader program outputting to the console. So I'm just going to run the parallax demo because I think that stress tests the tile data more than anything else. It's good to see that still works. So you should look at the original tile data video to get a description of what's actually going on here. But we've basically got a parallax effect by using the scroll registers and by dynamically updating the tile data. So let's have a look at designing the PCB that will take over this work. Tile data circuit is going to be heavily based on the tile map. Same 64 kilobit memory chip, address bus and data. Now we won't want the same memory region line, but we will want the load line. We want the 157s to mediate the incoming address. We need to latch those input lines. We're going to want to latch the output as well. And we're going to need one more 157 for the output. Right, there may be a better arrangement of these when we come to actually route it. Right, so that needs to control the top and bottom nibble, which we're doing here. So and that's the least significant bit. Okay, probably want to swap these inputs around. That's a workable layout. I could probably route that. Definitely a bunch of places around here where I could do with reordering things to make it easier. Alright, let's swap that one around. So that bit's instantly easier. Those lines are going to be tight. Maybe an opportunity to reorder them though. They don't look optimal at the moment. These are going to be pretty easy. Now, the important bit is though, we've got a rough idea of how big that actually needs to be. Right, let's see if we can route this before we make any hard decisions. So we need some decoupling caps. Now we still have the option of reordering the inputs here to make the addresses line up better. Not doing too bad though. Okay, well let's have a go at routing this. If I reverse these, this first set of signals would get really easy. Ten and 9 could do with swapping. Everything I'll do while I'm here is these need to be ACTs. I'm going to see if I can bring that select line out around the side. I'm going to hide the VCC and ground lines because they're going to be internal planes. Makes it all a bit more sensible. Definitely created quite the challenge for myself here. Oh, I've got a little chunk here that feels done. If I can deal with this mess, I can deal with anything. Need to double check the circuit I built. Alright, now I don't think I made that connection directly. Let's call that data output enable. So data output enable is the mirror image of mem output enable. That's the way I made it on the breadboard. Well, it's not the easiest connection in the world, but should be able to do that. These 5 are going to be tough. Needless to say, I don't like this. Okay, I've still got some very nasty lines to do, but I feel like I've put a serious dent in the work. Right, what's left? Definitely some reordering here is going to help. I'm going to swap these 3 round. There's not that many connections left. Right, now we have to worry about all the ground and power lines, although we're going to be doing an awful lot of that with the interior planes. Okay, this looks like we've got a completed circuit. I've actually got very little space on here. I don't think there's a lot of point now, but I will do the regular ground fills. Right, now that is a beautiful looking PCB, I think. No design rule errors. Beautiful. Right, I'm going to order this thing. I want to make a quick test PCB for this because I don't think we're going to be ready to make a full back plane. $125 wide. Let's see if I can make that a bit shorter. Okay, let's take a look at this. It's a very dense little PCB, this one. Now I've got a brand new tube of solder paste. See, this stuff comes with a little graph that shows you what the heating profile is supposed to be. Now I've got the multimeter with the logging capability and a thermometer. It might be interesting to actually try and run this and check what I'm actually achieving. Okay, slightly less than is ideal down there, but now, one thing I've been doing is anything that needs to operate at the full 25 megahertz uses the ACT series, and anything that runs at standard CPU rate uses the HCT series. This board is almost entirely ACT. That looks good. Okay, time to reflow it. Okay, quick inspection. Right, first up we need to get all the pins on. I've pre-cut the pins for that and the receiver pins to go in here, and I'm just wondering if there's an avenue to help these out. Hopefully, once the pins are soldered onto there, it should drop on quite easily. Actually, I don't know why I did that. This is now the perfect support. Nice little board. Now I don't have any 13 pin connectors, but an 8 and a 5 will do it. Just need to file the end very slightly just so they sit flush. Also don't have any straight 6-pin ones, but you can just straighten the pins and then trim them. This looks pretty good. I'm kind of disappointed that I needed to do this little micro back plane, but it's the only way I could see of getting the build incrementally put together. Hoping to avoid too many boards like that though. Okay, I can't see an effective way to test this on its own, so I think we're going to get the main build out and see how that goes. Right, so here's the PCB. Now some of these are going to be very easy, so that's the tile XY position. That's the 3 bits for each of X and Y tile sub-index. Tile data should plug straight in. And the address bus. Okay, so these are the control inputs down here. We've got 2 ground lines, the memory load line and the mem region line. So which were they here? Now that's going to the select line, so that must be the memory region. And I kind of bounce that on. We got the length to do it directly. Let's not fight that. Let's just move that over there for now. I don't want to restrict positioning in a bit. Memory load line, that's going to be this one. Okay, that's a bit restrictive on the length as well. Now both of those signals actually just originate from on here, so I would like to get the wires sorted to go direct. I've only got the one output for the memory load line, so I do have to multiplex it over here. Okay, there's an extra ground tie. Can make use of that there. Right, that's the clock line. That goes there. And this will be memory data. Let's not forget that. Now we've got the outputs, but we've got power and ground in here as well. Might be worth looking for a longer one there. Right, outputs are a bit trickier because we generate 8 output bits here, but we've only got 4 here because we just pulled the upper 4 bits low. That's interesting. We actually put the lines here the opposite way around that we'd want. So bit 0 is on the left. Just going to use this longer DuPont cable to tie those to ground. Okay, well, nothing left to do now but try turning it on and hope it works. This is one of those times when I get to find out whether or not I'm quite close to the end of recording the video or whether or not I've got a whole bunch of diagnosis and possibly soldering to do. Okay, I don't like the look of that. We're not getting a VGA signal out. Right, let's power that down. That's a terribly bad start. Power and ground the wrong way round. Okay, let's hope we haven't blown anything up. Oh, beautiful. The logo's up there, which is a very good sign. So the parallax demo is a bit of a stress test again. That works. Try the parrots again. Yep, that's there. I do need to spend some time improving that code though. Let's try our very short maze program. That works as well. That's fantastic. Very lucky we didn't blow anything up with the power line swapped over there. Tell you what, when I do a kind of next generation build, I'm going to consider putting power connectors in which are keyed so you can only put them in one way. It's not going to solve every problem, but it would have saved me here. I feel we got lucky with the power there, but apart from that, the circuit worked first time. I'm probably storing up some bad luck for future problems, but let's ignore that for now and be grateful that it works. Okay, I hope you found this interesting. As always, I'd like to extend a special thanks to my patrons and all the other people who comment and support me in different ways. I very much appreciate it. Thanks for watching, and I really do hope you found it interesting. Goodbye.